I want to start it how I always start it, but now I'm going to do it in Espanol. This is going to be a shout out to, who was it? Itzel. Itzel asked for this, so I got you. Tengo que dar la gente, dar la gente que quieren. Wow. I tried, yo. Google Translate. We'll see if it worked. All right. So, got a big video today. The first part we're going to talk about is going to be some Gema table basics. So write this down. A Gema table is a way to deconstruct everything that is happening in an equation. It follows the order of operations to create the table. So go ahead and get that down. All right. So many of you all saw this last year. But we're going to do this year is make sure that everybody is on the same page. And most of you probably haven't thought about this a lot since freshman year or since last year. So I want to give you a quick refresher. So let's start with a Gema table. We'll make a Gema table about something like this. Let's say, so example, y equals 4x squared minus 9. Okay, we're going to make a Gema table for this. So the key is, first off, you have a table. So let's go ahead and make your table. Right here, you have a heading. We don't know how many things we're going to need, but boom. We always start with x, and we're going to end up with our y, okay? So in this equation, if we follow Gema, which is our order of operations, it says you do groupings first. There are no groupings, okay? So we're starting with x. We're going to build to this. You do exponents second. So what happens to x? It gets squared. Notice, we need both of these parts. So I'm going to be looking for both of these parts in your equation. So x, when you square it, you get x squared, okay? So now we've just built x squared. We did exponents. Next is multiplying or dividing. So it gets x squared now gets multiplied by 4. So I go times 4. And now x squared times 4 is 4x squared. And now after multiplying and dividing, it's adding and subtracting. So now I subtract 9, and I have 4x squared minus 9. Notice I built it. I started with just the x. I squared it. I multiplied it by 4, and I subtracted 9. And I can see all of those, right? This is like my y column. This is my output column, okay? So I just built this with a Gema table. And now I can plug in different inputs to figure out what my outputs are. So let's say x is 0. But here's the really cool part, right? Well, 0 squared is 0. 0 times 4 is 0. And 0 minus 9 is negative 9. So if x is 0, y is negative 9. I could show that, 0 squared, 4, negative 9. All right? But now I want to see, it's nice because I can use this. Well, what if x is 3? I don't know. All right, 3. 3 squared is 9. 9 times 4 is 36. 36 minus 9 is what, 27? When x is 3, y is 27. We'll do one more. Let's say x was negative 2. Negative 2 squared is negative 2 times negative 2. So that is 4. 4 times 4 is 16. And 16 minus 9 is 7. So I just built a Gema table for that. And I showed you how to use it. All right. We're going to build another Gema table, and this one's going to be more similar to what we're actually going to use for our class. It's going to say, oh, let's go y equals 5 times x minus 2 squared plus 12. Okay, so again, I'm going to set up and I'm going to build this Gema table. So boom, boom, boom. I don't know how big it's going to be, but I know I'm always going to start with x. And I'm going to follow Gema. Grouping. I see inside the grouping, the first thing that happens to x is subtract 2. This is key. So x minus 2. No more grouping. Exponents. So I'm going to take that and I'm going to square it. So this becomes x minus 2 squared. No more exponents. Multiplying or dividing. I can see it's multiplied by 5. So this goes times 5. So now it's 5 times x minus 2 squared. And finally, adding or subtracting. This is adding plus 12. So 5x minus 2 squared plus 12. This is where I end up. Here's my input. This will finally tell me what my outputs are. Okay? And again, I can use some random numbers just to check. So if I want to know, well, what if x equals 10? Cool, put a 10 here. 10 minus 2 is 8. 8 squared is 64. 64 times 5, I have no idea what 64. Oh, 640 is 64 times 10, so 320. 320, and 320 plus 12 is 332. All right, I'll do one more. Let's say x was, I don't know, let's say it was -4. -4 minus 2 is -6. -6 squared is 36. 36 times 5, well, 36 times 10 is 360. Half of that is 180. And 180 plus 12 is 192. All right, so yeah, the cool part about this table is I can also use it going backwards. All right, so let's say in this situation, I knew the output, or y equals 12. I can start here, but now I can just do the reverse, the opposite of everything that happens up here. So 12, this said plus 12, but if I'm going backwards, that'd be minus 12, so that'd be a 0. 0, it says times 0.5, but I need to divide by 0.5, so that'd be a 0. 0, this says square it, but I need to do the square root because that's the opposite, and the square root of 0 is 0. And boom, boom, 0, this says minus 2, but I need to do the opposite and plus 2. 0 plus 2 is 2. So I can use this thing going forward and backwards once I've made it. So it helps make the calculations actually pretty easy for a lot of these functions that we're going to use. All right, so that's what a Gema table is. Now, the next thing we're going to talk about is how do I use a Gema table and what does it have to do with this vertex form? All right, so we're going to talk about quadratics in vertex form. All right, so just please get this down. So there are 3 ways that you can represent a parabola. And remember, quadratics all make parabolas with the function. There are 3 types of ways you can do it. There are 3 forms. There's vertex form, which we're going to talk about here today. There's factored form, which we're going to get to probably sometime next week. And there's standard form, all right? We're only focusing on vertex form with this one, all right? So this vertex form, you're going to use this when you know the vertex or when you need to find the vertex, right? If one of the key features you need is a vertex, you're probably going to want to deal with the vertex form, all right? So the vertex form, I'm giving you an example. Looks like this, y equals -5 in parentheses x minus 2 squared plus 7. It always has a format like this. Y equals, there's some number here, in parentheses is x minus some number here. It's squared because this is a quadratic. It creates a parabola, which is why it is squared. And some number is added or subtracted at the end. This is the basic form in vertex form. But one of the cool things that you will start to learn really quickly is I know what the vertex of this parabola is right now just by looking at it. This parabola has a vertex, meaning either the maximum or the minimum, depending on if it's concave down or concave up. It has a vertex of 2, 7. I see the vertex right here. It's always the opposite of this. So this says minus 2. It's 2, and it's the same as this, 7. All right? So I'm going to give you one more example of something in vertex form.